Hello, everyone. Good morning, good afternoon, and good evening, wherever you're watching this workshop from. Welcome back to another workshop. Today's workshop is going to be on Introduction to Hardhat. I am Harpal from the Celo DevRel team, and today we are going to go through how you can use Hardhat for testing and deploying your contracts, Hardhat, and using Hardhat and a lot more stuff. So, without wasting time, let's jump in. So today's agenda is basically what is hardhat, right? Why do we need to use hardhat? We'll be doing a hands-on workshop, so we'll be using hardhat. I will be giving you some examples on how you can use hardhat in your own projects. We'll go through basic hardhat commands. We will see a smart contract overview of a smart contract that I've already prepared for this workshop, going about how we can test that smart contract, deploying, and then finally verifying the smart contract on the Celo blockchain. So, what is hardhat? Hardhat is basically a smart contract development environment. Um, so, for example, you must have come across Remix as well, and we did a workshop on Remix as well, right? So, hardhat consists components for compiling, testing, debugging, deploying, and verifying your smart contracts, and actually many more components. But the reason you would use hardhat is when you want to do smart contract development in your local environment, right? To give you an analogy, let's say you are doing a React project, right? You can write the entire project in code sandbox, but would you do that, right? The question is, you would you write your entire project in code sandbox? And the answer is probably no, right? You would use, like, if you want to test out something, then you would write it in a code sandbox, and that's why it is for, right? And similar is Remix. You If you want to test out something quickly, if you want to see if your code works or not, if you just have a single contract, then you would probably choose Remix, but not if you have an entire suite of contracts, right? And that is why things like hardhat come into play, right? That you would use hardhat to do development, smart contract development in your local environment like VS Code, right? Other than that, hardhat also gives you features like forking the entire mainnet and even impersonating wallets. So, for example, you want to test your contracts with the state of a chain, right? Then you can have, if you have access to an archive node, then you can fork the chain and simulate the environment in your environment, like for your smart contract, right? Let's say you want to get access, you want to see that if I interact with my contract from the perspective of this wallet, are there any ways that this wallet can do something with our smart contract that it shouldn't be able to do? That's why it can even impersonate, it lets you impersonate wallets as well. If for a particular wallet they have some kind of a lot of assets, they have special NFTs or assets that you think might be that you are like suspecting that might be able to do something wrong with the smart contract, then you can impersonate, like use you can basically interact with your smart contract impersonating as that wallet. Obviously it's not going to give you a private key and all of that, it's just going to simulate that environment for you. So that's and then there is a lot of tools available in HANA that we'll go through today. So let's jump in directly, right? Let's see some code, and let's see how we can use hardhat in our own projects. So before I jump into my own screen, if you want to follow along, I have the link to the project that I have, uh, the project that I'll be creating from the end of the workshop. So basically, you can use the following link that I have pasted in the chat, the live chat, and you can follow along if you're following along. So, yep, let me just switch to my screen. Okay, great. So the first step is that you would need some prerequisites. Okay, so the thing that you would need is a node. So if you don't know if you have node or not, what you can do is you can type node hyphen v, and then you can check if you have node. If it returns a number like this, then you have node. You also need npm. uh, this is how you can check if you have npm or not. And if you don't have it, what you can do is you can uh, go to you can search for node.js, go to their website, and download the LTS one, recommended for most users. Once you download and install it, you can run these commands again. In case does not give you the numbers, like the version numbers after installing it, try restarting your terminal and check for it. You should be able to see it. In case you are still not able to see them, then you can approach us in the Build with Celo hackathon discourse. Okay, so the first command to execute is npx hardhat init. Right. Before that, let's create a directory. So PWC workshop, do the mkdir workshop. Now let's run a command npx hardhat init. What this basically means is we are trying to initialize a hard hat project. The team at Hardhack has done a really good job at making this command. So basically, when you hit enter, it will ask you what type of project you want to create, which type of language, like what do you want to use TypeScript or not, all of that. So for this, I'm just going to create a simple JavaScript project. Um, if you're doing this for the first time, it might ask you to install hardhat as well. If and it should say that type Y to go ahead. So just type Y and hit enter. And yeah, I'm going to say create a JavaScript project, and it's going to ask for what is the project root. You can see the path of the directory. I'm just going to say yes. Do you want to add hard git ignore? I'm going to say yes, and you can say yes to this as well. And now it's what we're doing is basically initializing the project by downloading some files into the folder that we are in, and installing some dependencies as well. So it will have um, all the basic files that you would need in order to get started with a project. Depending on your internet speed, it will take a little bit of time here. By the time it downloads, I can give you a walkthrough of the project that I have here. So this is how it will look. If you once you clone the repo, uh, you will have a scripts folder, you have a contracts folder where I have a contract. Um, you won't have the node modules folder because you have to do yarn or npm install so that it installs the dependency, and then you will see the node modules folder. We have a test script as well. We have hardware configuration file as well. All of these, most of these files will be generated by the command that we are executing. So once it's done, this is how it should look like. Let's open VS Code in this folder. So this is how the directory should look like for you when you do npx hardhat init. If you open up your contracts folder, you will see that there is a contract. This is the one that is supported by the hardhat team. Um, there's a deploy script as well for the same contract, and there's a test file as well, with test cases for the uh, same contract, the log contract. And then we have a hardhat-config.js as well. This is where you would write your configuration. So this is the overview of the project. Um, let's go over some hard hat commands when we have this. Like you can start, uh, testing out the commands directly when you are like just initialize the project itself. So the first command that one would do is hard hat compile. This command will basically compile the contract that you have in the contracts folder, so which is log.sol. Um, And yes, you can change the compiler versions here if you want. 8.7, whichever you like, 8.17, whichever you want. You can just type it there and it will download the respective compiler and compile the contracts using that compiler. Once you have successfully compiled the contracts, you will see this artifacts folder. which has the information related to a build. Uh, if you go to log.json, it will have the ABI of your contract with the bytecode, deployed bytecode, all of that. It also has a cache folder. So um, this is how you would compile. So like when you're done writing your contract, you want to compile them to check for errors and all of that. Other than that, we also have a command called node, which is basically running a local blockchain in the terminal itself. So if I execute this command, then it will basically give you private keys and accounts, which will be obviously local for you. So basically, this is like if you have used Ganache before, then this is basically that. It will give you some accounts to play with, some private keys, with some balance, which is 10,000 each, right? And all of this is happening locally. So um, let's open a new terminal and show. I will show you what's the use of this local blockchain. So let's say we are done compiling, our contract, and now we want to deploy it, right? We would do hard hat and run. So using run, you can basically execute any JavaScript file. So uh, scripts and deploy.js. This is the file that the hard hat team has provided us when we initialize a project. And in network, you can write localhost, okay, because the blockchain that we are using is hosted locally, right? So localhost. When I enter you in the terminal, you would see some changes happening. You can see that we basically did a contract deployment, and the name of the contract was lock, and this is the contract address that was deployed, transaction hash, and the from address. If you notice, the from address is basically the first wallet that is provided by the hardhat node command. Okay, so this is basically how a contract compilation and deploying would work. But this is all provided by the hardware team, right? Like, let's do something that is of our own, right? So, okay, one thing, if you are going to change your contracts and you want to compile again, then it's okay to compile them directly, like using the command compile command. But sometimes, if you feel that your uh, build is out of sync of your updates, then you can do hard hat clean, and this will basically remove your artifacts and also clear up your cache. Great. So now let's delete this logs.sol because we are going to try out a contract of our own. And I have a contract created. I have a contract code ready for called todo.sol. So let me copy that code over here into our project. So briefly, I will explain what this contract does briefly. First line is basically saying that the license identifier is unlicensed. Basically, anybody can use this code. This is the compiler version. As I said, I'm using 8.7. So if we go to our config of this file, we can even add multiple compilers, 8.7, 8.9, all of that, right? So if I want to change my compiler version here, what I will do is just do this, and this way I can now compile my contract. I could have compiled my contract with 8.17 as well because I have this caret sign here. um, so the contract to do basically has it's basically a to do list contract where I have some tasks. Every task has some description and a boolean which says whether it's complete or not. Then I have a task counter which basically keeps track of how many tasks I have in the contract. Um, every task is attached to a unique number, and then we have events and for task added and task completed, function to add a task and is completed, basically checking whether the task is complete or not, and mark task complete, where you would call this function with the task ID, and then it will mark the function as completed, right? So what would be the uh, test for this contracts, right? Like, let's say this is the contract that you have written and now you want to write test, right? So uh, let's first create a test file, and you're in the test folder. Let's call it todo.spec.js. And then we can basically import this three uh, imports. And the first import is basically expect, which is from the library chai. Expect is basically a comparison function where you would put you would put something, and then the second thing that you want to compare it with, if they don't match, then it will throw an error. uh, we will learn about what this load fixtures means, and ethers is basically for deploying contracts and utilities and all of that. Let's also copy all this. So the first line basically means describe. This is more for test management. So, like, let's say in your single to-do contract, you have different phases, right? Your contract has, let's say, when particular thing has happened, then the contract is in a different state, and then there is a lot of test cases related to that state of the contract. In that case, you can segregate your test using describe. Okay, that is one way of doing it. In this case, the contract is too small, so I don't need a more than one describe block, but you can if you want. And then we have some fixtures. So the what a fixture means is that um, it is a setup for every test. So fixtures are basically set up for every test. For example, if I want to give you an analogy to a real life situation, then let's assume that you are trying to perform some tests in a chemistry lab, right? When you are performing tests with chemicals, there are a lot of steps that has to be performed before you start your test, right? You set up a table, you wear gloves, you wear glasses that protect your eyes, you have to clean the test tubes, right? All of that. And this has to be done every time we start doing testing, right? And this process is repeatable. So in code, obviously we don't write code again and again, right? Try principle, right? So for that reasons, we have fixtures, which is basically a set of a code which is going to which we need time and again for doing a testing. It could be executed before the test begin or after the tests are complete for cleanup, maybe, right? So I have a fixture called deploy to do, and the name says it all, right? Uh, this fixture basically deploys a fresh to do contract and returns the fresh instance of a to do. So when you're performing tests, when you are done with one test, then you might want to test on a fresh version of the to do contract, and that's where you would use this fixture, right? Rather than writing the code to deploy it again and again, you would just write load fixture and then write the name of the fixture, and then you would get the to do, which is a fresh instance, right? Which is like a fresh instance of the to do contract. I have another fixture which is one task added, and this basically represents the state of to do when there is a task added to do, right? Similarly, I have one task completed, which basically returns the instance of the to-do contract when one task is marked as completed. So this way, I have some fixtures, uh, written up here, and you can have similar type of fixtures for your own contracts, right? Depending on what your contract does, right? And once we are done with fixtures, we start writing tests, right? And all uh, the functions which are with it are basically test cases. So it should be able to add tasks. What this test basically does is that this test basically tests whether we are able to add tasks to the contract or not, right? So the first step to do the test is basically loading the fixture where we deploy the to do, because we want a fresh instance of to do and we want to add a task to it, right? So what I'm doing is, as I said, expect as a comparison thing. So what we do is it's an async operation. So we do expect, and then we write the thing that we want to perform, which is to do dot add task. How am I doing this? Because this is so this first line is basically getting the to do contract, and the second line is where you could pass arguments here. So you would pass your arguments here, and this to do is basically the contract. Okay, so if you want to execute a function, let's say add a task, you would do to do dot add task, and then this contract basically takes a string, which is the task, right? And then adds it to the description. So my task here is that submit idea to BWC hackathon, right? This is one of the tasks. And when I add this task, I know that my contract should emit an event, right? And the my contract to do should emit an event called task added, and it should emit the event with an argument 0, right? 0 is basically um, the task number for the event. So if I go to my contract back, um, what I've done is that we first get the task ID from the task counter, which is initialized to 0 when we start. So task ID is 0. And then in the task mapping, add the 0th key and the description. 0th key, we would have a task object, and then its description would be task, which is the string, right? And then I would emit an event task added with the task ID, which is 0, right? So this is basically what I'm checking for, that whether when I did this action, did it emit an event task added with the argument 0, right? And how did I know that this is the syntax for this? For that, we can go to, let's say, the documents. So if you go to documentation, and let me show you documentation and chai-matchers. And when we do learn more, you can go to reference, and then you will see the syntax to check numbers, right? Total supply to equal to deep equal, reverted with. We have emit, right? For events, we have emit. So this is how you know this is the syntax, right? Expect, and then you perform the task, and then you know that it should emit an event. So you basically type in the contract name that should, like, the contract name, you have to provide the contract to for the test suite to know which contract am I supposed to listen to for events, right? And then the name of the event, and then we can have with args as well. So if your event has if your event is going to emit a value as well, then you can check for it with args. Okay, so this is trying to add a task and expect everything to be okay, right? Like expect that we get an event, and then we can also check whether like a double check whether the task 0 has a description of what we sent in, right? So this is a public one, right? So we get a since this is public, we get a getter function by default, and the name of the function would be task. So we can do to do dot task and 0. So basically checking for 0th key, and at 0th key we have the task object, and we are checking its description, and it should match with what we have sent, right? So this should return this, right? And to this is how, like, you would check for your like this is how we would test your add task function, right? Like this is how I would test it, right? Similarly, your contract might be doing other things. You can check it in a similar manner. Just to check, do we have any questions? Okay, we don't. Okay, cool. So Um, another thing, since my test suite here has more test cases, let's say your test suite also has a lot of test cases, right? And it takes a lot of time to run tests if there are some async operations, right? So one thing you can do is you can type it dot only, and this will basically execute only this test case, right? So how do we execute a test cases? The biggest question, right? So the command for that is npx hardhat and test. It's downloading the 8.7 compiler because I changed it in the configuration. And you can see this to do comes from describe. here. Okay, and it only executed one test case, even though I had one, two, three, and four test cases in my file. It just executed one because I typed only, right? I modified it to only. Should be able to add task, and it's a green tick, which means it's a pass. Now let's say I change it to like make a small change, and let's see if it executes. Like, do we get a pass again? Right? We don't, right? It says assertion error. Expected submit idea to be display hackathon to equal to submit, right? Basically, we are expecting it gave a error because we are expecting this statement to be equal to this statement, which is not true, right? And that's why it gave us one failing. So it gives a pretty good description of why the task, why the test failed, right? So let's change it back, and let's remove this only so we can also talk about the other test cases here. Uh, the second one is should be able to mark task complete, right? Now, this is where the first one of the fixtures that I created would be helpful, right? Because I'm here testing whether we are able to mark the task complete or not. And in order to be able to mark a task complete, we should have a task already in the contract, right? That's the first thing. So that's why I have this fixture here, which basically adds a task, the basically the same step that we did in a previous test case, and then returns that instance of to do. So this to do instance is returned here, and this instance has one task already added to it. So there is already one task in it. So again, we use expect, right? This is the assertion function where we can compare two things. So we are basically trying to say to do dot mark task complete 0, right? So if I go to my contract back here, you will see that there's a function called mark task complete, and then you pass it the task ID, and then it performs some check, and if all of them are true, then we will mark the task as complete. So when I mark that task as complete, at the end I also emit an event task completed with the task ID, right? So that's exactly what I'm checking here. Uh, that when I perform this operation, I also want I know that my contract should emit a task completed with arguments 0, right? The 0 is the ID of this task that was added, and it's not 1 because, as I said, task is added to a fresh instance of to do, right? So the one task added fixture uses another fixture in itself, and this can be done, right? We are basically deploying a fresh to do contract and then adding a task, and then we are trying to mark it complete. Let's say I misspell, uh, let's say I misspelled it in my contract, right? Let's say, uh, for example, let's say, remove this K here, and then I remove this K here as well, and then I run the test. Let's say I made a typo in my contract. Now, if I do npx hardhat test, it knows it failed because task completed doesn't exist in the contract, right? I forgot to mark it only. Let's do it. I accidentally shut down VS Code. Okay, no worries. So if I do hardhat test now, you can see that task completed does not exist in the contract, right? And that's how you would know that you made a typo. If you go back and you see, okay, why does task completed does not exist? It should be, right? But then you would know, oh, I misspelled it, right? And that's where you would put in a K. And now if I run my test, it passes, right? So that's how you would be testing your contracts. Um, Similarly, I have another test for should not be able to mark a task which is already completed, right? So this is a thing which a user should not be able to do. So I have a fixture for that. Again, I have one task completed fixture, which basically is a fixture which marks a task completed, right? Again, it uses the fixture above it and then the fixture, and that uses the fixture above it. So this is how I am like stacking fixtures, right? One above the other. And this instance, as a task added and it is marked as completed. Now what I'm trying to do here is I'm trying to mark it complete again, right? And this time, my condition that I've set is to be reverted with, right? So the test should actually, so you when you're writing test, you have to write the condition which should actually happen, right? And not what your contract is going to do, right? According to our requirements, it should be reverted, right? The transaction should revert because we are trying to mark a task which is already complete, right? And again, let's do this and run a test to see that it passes. And how do I know that it reverts with this statement? Where does this statement come from? If I go back to my contract, if we go to mark task complete function, we see that first we check if the task ID is less than task counter. So this condition basically checks, let's say there is two tasks in your contract, 0 ID and one, the task with ID 1, and someone tries to mark task complete with ID 2. In that case, it should revert, right? Saying that there is no such task in the contract. What are you trying to mark as complete, right? So that's the first required statement. And the second required statement basically says that uh, is completed task ID that we have passed in. So this function basically checks if the task is already completed or not. And if it is, then it returns true, right? And we do the exclamation to do the reverse. So basically how the required statement works is that if this thing is true, then it goes ahead. If this thing is false, then it will return this statement. So uh, when we pass a task ID, which is 0, it sees that it is completed, and then we do the reverse, which is false, and that's why it returns the statement, task already complete, right? That's how the required statement works, and that's how this comes in. Let's say you know, for some cases, let's say return the same statement here, right? And I test for task already complete statement. And again, if I do run my test, it will give me error because the transaction was supposed to be reverted with task already complete, but it's reverted with no such tasks, right? So the revert message was incorrect, and then you can like come in and uh, correct it, right? So that's how you would check for the reverted statements, right? The task test where your contract should revert. And again, the last test case is the thing that I just explained, that if I have a fresh to do, like I'm loading a fresh to do contract here, and this contract basically has no task in it. But what I'm trying to do is I'm trying to mark the task 1 to be complete. And that's where I should get the following statement, right? So if I remove the only from here and run my test, would see that all my test cases pass, right? And this should even work with 0 because we don't have any task in it. Oh, okay. I might have, okay, so yeah, I know why this is not giving no such task exists, because if the task counter is initialized to 0 and task ID is also 0, no such task exists. So it exists, so it reverts with, oh no, but this is true, right? This is false. Let me check it again. This is how you would be going, right? Like this is what's going to happen with you as well when you're testing your contracts. You'll be going back and forth and like figuring out where your contract fails and all of that, right? But let's keep it. Let's skip it for now. But yeah, definitely we can take this into GitHub issues if you're interested. Um, because of the time constraints, I will just move on to deploying. So so for deployment, we keep our scripts in the scripts folder, and this is the script provided by the hardhat team for deploying the lock contract that we have already deleted. So if you want to deploy your own contract, you can remove this code and start writing your own code for deploying your own contract, right? Which could be different because your contract takes in some arguments, right? Which log.sol might not be multiple arguments. Then you want to do some extra steps after deploying. All of that can be done here. So I also have a deploy.js prepared for the project. So I'm just going to copy that and explain what this means. So the first step for deploying is we need a signer, right? And when this statement is only needed when you are trying to deploy to your local host network in Hardhat, right? So the first thing we need is a signer, right? The person who would deploy the contract. So we using this ethers.get signer, you can take out, it gives you 20 signers, right? How do I know if it gives 20 signers? Because when we execute the command hardhat node, we saw that we got 20 accounts. So those are the 20 accounts that this command can give access to. And we take out the first one and call it deployer. So, and then using this statement, we get the contract factory, right, for to do. By typing in your contract name here, you can get the contract factory. If you had a contract called log, let's say, then you would type in log, but we have to do, so that's why we have to do here. This variable can be anything, but for uh, semantic purposes, I kept it to do. Then we can do to do.deploy, and it's a async, obviously, a task, so we'll have to await it. And here you would pass your arguments if your contract takes any, right? So if I go back to my contract, I don't even have a constructor, right? So my contract, the contract that I have here does not take any arguments at deployment. So that's why I don't need to pass in any arguments. But if your contract does take arguments, then you would put it here. And this is the instance of the deployed contract, right? And then I can access all the properties on it, like I have here, to-do.address. And just for demonstration purposes, I have a console log here, which gives us the address of the deployer and the address of the deployed contract. So let's execute the script and see how we can deploy our contracts. So let me clear this out first. And yeah, let's run our hardhat node, px hardhat node. As you can see, we have account number 19, but the first one is 0. So we have 20 accounts. And yeah, when I type the command npx hardhat unscripts, I think I already demonstrated this. So yeah, okay. So uh, you must have noticed that nothing happened on the left side, right? Because hardhat actually has two networks. One network is called hardhat, and the one that is executing here in the terminal is called node. The one which is called hardhat, it actually starts and then stops right after your script ends, right? So that's why like it keeps on starting and terminating itself when you run commands that need a blockchain, a local blockchain. So you won't be able to see results for that network, right? Like you can do here. If I execute the same command with the network flag as localhost, then you would be able to see changes here, right? Because this network that I'm have here on is the local host one. Then there is another one which is called hardhat, and you won't be able to see like a visualization in your console for that network. So uh, let's check if everything is true. Deployer address, if we go to the first wallet, we can see 2266 that's right. And we have the address of the to-do contract that was deployed on a local blockchain. If we can see a contract deployment to do, contract address is 0A3, 0A3, right? And the from addresses are deployer. The value sent in was 0eth because we don't need any value to be sent on deployment, right? So this is how deployment would work. Now, let's say you want to deploy the same contract on the Celo testnet, right? Let's see how we can do that. I'm going to stop the local blockchain, and now if you move on to hardhat-config.js, you will see that there is just one configuration done here, which is the version of Solidity compiler that you want to use. But if you go to the config file that is in the GitHub project, you would see I've added a lot more information, like a lot more configuration, which you can also add. Basically, saying which networks you want to support in your project, right? Which networks are you going to use for deployments? You can specify all of them. I have Alfajores, which is the testnet, and then I have the Celo, which is the mainnet, right? And then I have the URL, which is basically the RPC URL. It can be any URL of your choice. I have the one that I've taken from the docs. Same for Celo mainnet. And then there's this account property where you can paste in your private key, the private key of the wallet that you want to use for deploying your contracts, right? So you would take that private key and put it here. One thing that you have to make sure is do not commit your code if you have the private key here, right? Don't commit it to GitHub, okay? Because then it will be visible to other people as well if your repository is public. Same you can do for mainnet, right? Uh, right now we deployed a contracts using the signers or the private key and account that Hard had provided us. But what if you want to do it with our own, right? That's how you would do by putting in a private key here. And down here we have Etherscan uh, configuration. Basically, using this properties or like you putting in your key here, you can verify your contracts on the Celoscan Explorer, right? So if you take in your Celoscan API keys and put it here, and then run the command for verification that we will see in a few minutes, then you will be able to verify your contracts on the Explorer, right? So that other people can view the code. So what I'm going to do is I'm going to basically unshare my screen for a while so that I can put in this values here, and then I will show you how we can deploy the contract on the Alfajores testnet and then verify it. Great. Yeah. Okay, great. So I have my keys and everything. Okay, I think I showed it, but no worries. I don't mind because these are just test wallets. So this is how keys would look like when you have pasted them into your contract. Don't use these keys again because they are live and everybody knows it. And I don't mind because I have just test tokens in it. And the ones below here are the keys that I got from Celoscan. So how would you get it? For that, all you have to do is go to Celoscan Explorer, and then if you like click here, you would see that it asks you to sign in and or sign up, and then you sign up, and then you can go to API keys, and that's where you file your API key. And you have to make sure that you are on the Celo mainnet. If you go on to Testnet, I don't think you'll see a sign in option there. Yeah, right. So yeah, the key works both for mainnet and testnet, so you don't need to worry about that. And finally, let's go and deploy our contracts. So let me clear this up. The command is same. Uh, npx hardhat run scripts and deploy. And obviously, the network flag is where all the change happens. Rather than putting localhost this time, what I will do is I will put Alfajores, right? So Alfajores. Enter. And this time it's going to use the account that is derived from this private key, right? And you can see we have the deploy address, which is different, and we have a to-do address. Now, if we take this to-do address and go to the Alfajores Testnet Explorer and search for it, you can see that we deployed a contract 11 seconds ago. If we go to the transaction, we can even see who did it. So if we cross verify 51DF, that's the one, right? Now, if I go to the contract section, you can see that, if you want people to see your code, which is a good thing, you will have to go to the process of verify and publish, which is form filling and copy pasting API and all of that, which is tedious, right? And that's why we created this utility called hardhat-celo. So if you go to npmjs.org, we have this utility called hardhat-celo package. Using this package, you can verify your contracts on the Alfajores testnet. So let's do that, right? Okay, let's open that up again. So basically, all you have to do is install this package, hardhat-celo, and then you have to add this require statement in your config and remove this one, comment it out. And then all you need is just the configuration, right? You need to have your private keys in, you need to have your API keys in, right? And then there's the command to verify on Alfajores testnet and the Celo mainnet. So let's take this command. Let's wait until this is done. Okay, cool. So the command basically is npx hardhat verify, and then you would put your contract address. So let's take that from here. Paste. We don't have any constructor arguments, so we can remove that part. And then again, we need to specify the network we want to verify our contract on. So network is Alfajores. Starting to compile because the contract's already compiled. And now it's sending a request to verify a contract. And then it says successfully verified. So if we go and refresh, we can see a green tick. And if we go to a contract, we can see that a contract has been verified. And we can see the code as well. We can even interact with the contract right from a browser. So, yep. And you can also see the ABI and the bytecode. Yep. That's basically it for the workshop. I hope you learned something new. And yeah, we are open for Q&A at this point. So if you have any questions, this is the time to ask. Um, if you don't have any questions, that's fine. But in case you're watching a recording and you have any questions, you can reach out to us in the Celo Discord. You can reach out to us in the Build with Celo Hackathon Discord. We also have office hours. There's going to be office hours uh, tomorrow. And so we do office hours weekly on Tuesdays and Thursdays. So there's an office hour tomorrow at 1 UTC, 1 p.m. UTC. So, and this will happen in the Build with Celo Hackathon Discord. And then there's another, which one is on Thursday at the same time. We also have a poll on Celo devs to select a time zone that you would be comfortable with for the office hours. So if you are willing to, please participate there. And yeah, that's it. Have a good day. Thank you for attending the workshop.